All right, boys and girls, welcome back to the drive through. We're here with number 12 from 1-3. This is a tough question because we're going to have to do some difficult algebra. Look, we can't just put 0 in for x because we're going to get 0 on the top and 0 on the bottom. We can't divide by 0. So what we have to do is this little trick that's called multiplying by the conjugate. Okay, and so let me start by just rewriting the problem over here. I'm going to ignore the limit until we can get this in a fashion where we can plug in our x. So for right now, I'm just looking at x plus 3 minus 3 over x. I've simply rewritten the function. Now, the conjugate is this thing that we learned about in Algebra 2, and it's a really good way to help change the way that rational functions that involve ratios, which are just fractions, to help change the way they look. So what we're going to do is multiply by 1. We're always allowed to multiply by 1. The form of 1 is going to be the conjugate. So watch. That's the same. The conjugate changes that value of a binomial, and then I leave that the same. Okay, now I'm not allowed to do that unless I just multiply by 1. So on the bottom, I've got to have the exact same thing. So what I've just done is multiply my original function by 1. I'm allowed to do that. Okay, now watch what happens. There's like a little bit of magic here. It's really boring, but it's the only way to do this problem. So I've got to FOIL the top. Essentially, I'm doing that times that on top. Okay, so radical x plus 3 times radical x plus 3. I'm going to write all of this out just so you don't get confused. That's radical x plus 3 squared. Okay, well, those are going to cancel, but I'll get to that next. Then we'll do outside, so plus 3 times radical x plus 3, and then minus 3 times radical x plus 3. That's the whole point. Anytime you multiply a conjugate, it's going to eliminate those middle terms. And then 3 times negative 3 is a negative 9. Now, on the bottom, what do we get? Well, we're just going to call it x times radical x plus 3 plus 3. All right, that's what we get on the bottom. Now, the square root of something squared, like the square root of 3 squared, that's just 3. You know, it's the square root of 9. So this and that, remember, they cancel each other. So what we're left with on top is that cancels that. So it's x plus 3 minus 9. So x minus 6 on top. No, that's not right. X plus 3. Aha, I see it. I'm so sorry, Ella. Look, that's a radical 3. I always do this. This should be a radical 3. This should be a radical 3. That's going to make this just a regular 3. And what you'll have is x plus 0. Good. X, just have x on the top. And x times that on the bottom. Okay? All right, so let me rewrite this because I've now just confused you, and I'm sorry. The problem was I didn't write the problem correctly. So when I multiplied by the conjugate, I didn't have a radical. What we've done was multiply by the conjugate, then this tricky foiling, and on what you end up getting is x on the top and x times radical x plus 3. Gosh darn it, all of these should be radical 3s. Plus radical 3. Okay, cool. Now watch. X divided by x, that's just 1. So we got the limit as x approaches 0 of 1 over radical x plus 3 plus radical 3. Or now I'm to a spot where I can put the 0 in for x. I'm allowed to put it in. I just can't divide everything by 0. So you get 1 over radical 3 plus radical 3, which is 1 over 2 radical 3. Multiply by radical 3 over radical 3, and you get radical 3 over 6. That should be your answer. Hope that helps. Boom!